Like, sorry, should we wait, Sasha, for people to join, right?
Yes, maybe let's wait 3 more minutes.
Yes, yes,
We
yes.
can start.
Hello, Shield.
Hi guys.
Hi.
Sasha,
Hi,
you're
Rano.
the guy. You're the one that told me about the strategies, right?
Yeah,
Right?
yeah, exactly.
Okay. I'm studying stablecoin strategies today.
Nice. Nice.
Nice, nice.
Yeah, I was looking at what you said about the strategy for arbitrage, and yeah, most of the time the strategy are just are not built in a vault, or it's just like developer what that run their strategy on their own, and it's really hard to do like this enter in the MEV strategies, and MEV strategies are first super difficult to build because you have a lot of competition on Ethereum. You have a lot of people that are trying to extract money from the chain. So yeah, and so there are a lot of people
Yeah.
on it, and they are not sharing it. So it's always on their own.
Yeah. Actually, there are a few tricks and that was the second question that I was about to ask you, but yeah, I stopped at the flash loan. Anyway, the trick is called flash bots, so you can check that. And
The
it's
what? Sorry?
the trick to counter uh, the people who fast run you on Ethereum is called flash bots.
Oh,
And it's a community of people that basically they have their own RPC, which is masked, so you don't get front run by other people by the competition. So it's
yeah,
a way.
I saw
Yeah,
already some stuff building with flashbots. Really interesting. Like we need stuff like this to prevent, yeah, sandwich or
yeah. I think it
attack.
could be useful for you too, guys.
Yeah,
Yes.
yeah,
So yeah, I will check. I learned about Flashbot because some people from 1inch
yeah.
they have a relayer. They basically participate in the network, in the Fusion network on 1inch, and they use Flashbots. So
Yeah,
it
makes sense.
works.
Like, I guess the typical use case for Flashbot is swap. And yeah, on our side, like we have some strategies that are interacting with Uniswap. So in the first version, we are just going to directly interact with the swap and set a tight slippage. But later on, we will check what the solution to prevent to first have the most optimized path for your trade, and then how to protect MEV and stuff like this. But
Yeah, because once you get to a level, to an amount of investment, you get front run.
yeah, yeah,
And so, yeah, it may be useful. Okay.
yeah, definitely, definitely.
There are other ways. This is not the only way, but it's the fastest way, I think.
Yeah, yeah, yeah. It's easiest. And should we start the presentation? So Jill, you
Yeah, I
are
think.
the only spectator, so enjoy the presentation.
Yeah,
Yeah.
okay.
So like I'll start presenting Nimbora, like an high-level view of the protocol. How does it work? Why Nimbora, etc. So I have just a small presentation that I'm going to share. No. Okay. Can you see?
Yeah, yeah.
Perfect. Nimbora is about DeFi pooling. So the idea is to bring some DeFi solutions that exists on Ethereum and bring it on layer 2. So the idea of this is to allow layer 2 user to pay less fees and to create to add a lot of DeFi to layer 2 ecosystem. So how does it work down the line? So how can we save gas costs for this user that want to interact with layer 1 DeFi better than sending one request for each people? What we do is that we are aggregating multiple requests. So like a good analogy to this is like just a train that goes from a city to another. If you have only one person in this train, it will be like a big cost. But if you can bring a lot of people in this train, you'll pay the same amount for the, I don't know, the train traveling cost, but divided by all of the people present in this train. So here the same idea. We have many people. We are like handling one request for a large amount of people. So let's take example for a yuan strategy or Uniswap strategy. So you have some user on layer 2 that want to deposit or withdraw. What we're going to do is that we can match those people. So if we have like 100 deposit and 50 withdrawal of, let's say, the same amount, we will only consider like 50 deposits, because deposit from one user can be matched with a withdrawal from another user. After matching this user, we have like a big request. So in my example, it's a big deposit request. So let's say in yuan, like once a day or periodically, it will depend. We're going to handle this layer 2 request to layer 1. So we're going to bridge the liquidity from Starknet to Ethereum, and we are going to bridge message data. So the data we need. So here, based on all of the user requests, we end up with one deposit. So we need to say the layer 1 handler, okay, you need to deposit this amount of liquidity to the yuan vault. So we have layer 1 handlers that is going to receive all of those requests. So bridge are transferred via canonical bridge and messaging through built-in Starknet messaging system. So he's going to receive all of these requests from yuan, from Uniswap, for any of the strategies that have been registered, and loop on all of those requests and handle and interact with the strategy. So when it comes to yuan requests, we have plenty of strategy adapter. So the one for yuan strategy. So he will receive the deposit request, and in this adapter, it will be the logic to interact with the yuan vault will be written. So yuan vault, it's not exactly ERC4626, but it's like pretty similar. So for a deposit request, he will know he'll have to call the deposit function from yuan, and for withdrawal, just the withdrawal. So yes, that's how we can make this pooling work. Also, when people mint shares on layer 2, they directly receive a representation of they directly receive shares on layer 2, but they are increasing in price at each report. So when we are going to send the request to layer 1, the layer 1 will do the request and then send back to layer 2 some information. Especially the net asset value of what we hold on layer 1. So if it's a yuan strategy, between two reports, it has increased of a certain percent based on the strategy returns. And it will say to the layer 2, okay, this share increased this price. And now people can mint this share at this new price. So yeah, that's how we make this whole process that is initially like that is asynchronous, how we make this desynchronous simply.
Can I ask a question?
Yeah, sure, feel free.
Yeah, just about the other slide is about the mint function.
Yeah.
So you basically what you do is you mint fungible tokens or
Yeah,
unfungible
these
tokens.
are fungible. These are
These
fungible.
are fungible.
Yeah,
Okay, thank you.
yeah.
Okay,
So, yeah,
thank
if
you.
I get some Yarn strategy share, I'll get some Nimbora Yarn tokens that will represent my allocation in the holdings that are kept on layer one. So yeah, and yeah, it's fungible. We just have to increase the share price at each report. So there's nothing specific to a certain mint, and yeah. So yeah, the three main points to retain about Nimbora Yieldex is that it's gas efficient. So that's all about the pooling mechanism, aggregating multiple user requests into one request to divide the gas cost. It's synchronous, so shares are emitted directly, and we just increase the share price at each epoch. And it is modular. So we've built something very modular. If you want to add a strategy, a new strategy, let's say Aave, lending, a classic lending strategy on Aave, you don't need to build a Cairo code and a complex Redis stuff. You can override an abstract contract that is like a strategy base and implement the function to interact with Aave. And on layer 2 side, we just have a factory that is deploying generic code for any strategies. So it has the same logic on layer 2. So this is a big advantage we have. Okay. So this is the GitHub repository to access the Yieldex. So it will be about layer 1 contract, layer 2 contracts, and a relayer off-chain stuff to make this report works periodically. So this is a bit about, this is the contract architecture. So for the layer 2 side, we have a pooling manager. This is like the intermediate between messaging bridge and the strategies. We have a strategy factory. So as I said, the code is generic on layer 2. For whatever strategy, you will always have the same. So a token, a simple token that represents the share. So the Nimbora Yarn token, the Nimbora Aave token, or whatever. Then there is the token manager that is able to mint or burn Nimbora token, and like it's managing accountability, and it's the entry point for mint, withdraw, or whatever function. So when a user interacts with Nimbora, he's always interacting with token manager, and then off-chain service deal with pooling manager. So that's the layer 2 side. So we handle a new report. We are going to loop over all of the strategies and get the final request that is obtained after matching user, after, so one big deposit, one big withdrawal, nothing, or yeah, these are the three possible cases. So once pooling manager layer 2 get all of those requests, it will send it to layer 1. And on the layer 1, we have this also like kind of pooling manager that role is to that is also the intermediate between messaging and bridge and the strategy adapter. So we will loop over the requests, execute the task, so deposit, withdraw, or nothing, and get some data, so the new net asset value of the strategy. If it should bridge amount, it's always the case if it's a withdraw, for example, and send back information to layer 2. So yeah, that's it for the presentation. Then I'll give I'll let Didier talk about how to set up your Nimbora project.
Yes. Okay. Hello. So basically for this hackathon, so we created a repo that will show you basically how all like the services, the contracts, the off-chain and the on-chain services can interact with each other. So what we have here is sorry guys, do you hear this noise?
Yeah, that's
The noise.
No,
There
it's
is some.
no
Okay,
good.
okay, that's good. So let me grab the GitHub link. Okay, I will pass it. Nimbora.
Thank you, because I have another link.
Yes, yes. So this one. Oh, wait. Okay. Oh yeah, here I lost this one. Okay, so this is like the Nimbora Hackathon repo. Okay, that is basically a playground that will show you
Okay, okay.
how all the services interact with each other. So basically, we have three different folders. Let's first start with the contract. So we have L1 contract. So here, as Sasha explained it, so you can create your strategy and use different scripts that are we already implemented to deploy your strategy. Okay, so we have like some scripts that you can follow basically to understand how the process you should follow to deploy your own strategy. Then we have also the L2 contract, so same thing. So in this case, basically you don't need to do anything, so you can deploy your own strategy directly. So we have also like all those scripts, okay? So yeah, you need only to deploy. Basically, the flow is you implement your strategy, then you deploy it, you deploy L2 and do some configuration, okay? And all those scripts will help you to understand the flow. Also, yeah, one more thing. So we have the README that you can read, go through them. They will explain to you all the process for that. And then what we also provided inside this repo, a Docker Compose file. Okay, so as Sasha explained it, so to have like this communication between L2 and L1, because we have to send periodically a report from Starknet to Ethereum, process them there, and then send them back to Starknet. So we developed small services. Okay, so we have an indexer. So we are using checkpoints to index the L2 data. We have the relayer that is responsible to execute the reports. Okay, so basically handle there's function inside the L2 contract called handle mass report. So the relayer will initiate. So he will initiate the flow by calling this function one time, and then yeah, so basically it calls this function, it sends the message to L1, and then when the message on L1 is accepted, so the layer also process this message by interacting with the L1 pooling manager and so on. So he will, it's like a worker that will continuously processing reports between L2 and L1. So yeah, we have the indexer, and also what we have an API. Okay, so basically you can access to a Hasura API, GraphQL API, so you can basically query all the indexed data that are stored inside Postgres database. So you can query them on your front end and display to the user different information, build graphs. So yeah, so basically everything is already set up and easy to use. So yeah, basically those are the three main components of Nimbora Yildex. And here what we have global scripts. Okay, so we have this setup and deploy. Okay, so the idea is so what I suggest is you follow this script, what it's actually doing. For example, here, what we are doing is cd inside the L1 repo and execute setup.sh. For example, if I go here, so we are executing this one. And this one, what we are doing, we are installing packages, compiling hard, testing, deploying the L1 pooling manager. So we have some mock contracts that are used only on testnet. And then it deploys your strategy. So yeah, basically, I think this is the right flow to get like the idea how to set up your protocol. So yeah, so we have like to deploy the contract, and then when your contracts are deployed, okay, so you don't need to copy any address or do anything. So so this script handle everything for you. So you need only to then start your layer, okay, and then you will get access. So the layer will start consuming those reports, processing them, and then you have your API, and yeah, the indexer start indexing your contract. So basically, you get everything out of the box. So yeah. And then when you are like done, you tested everything, so you can call this script basically to clean up all the Docker Docker containers. Okay. And yeah, so only for the relay, so the relay is really light. Okay, so it doesn't like consume a lot of resources, so can run it on your local machine, so without any issue for testing. So yeah, I think that's it. Do you have any questions, Gilles, about that?
Yeah, the setup is for Goerli, right? Testnet on Goerli.
Yes, so what we have here, so we have .env.example, okay? So you can clone it, so you can duplicate it and rename it to .env. And basically, if you want to deploy it to mainnet, so you come here and you select mainnet instead of Goerli by default, mainnet. And then what you need to do is, for example, providing Ethereum RPC node, not Goerli. Yeah, and it should deploy everything to mainnet. Okay, so that's
okay.
So yeah.
So it's as is set up for testnet, and then I can change that and put it and
yeah
configure it for mainnet. Okay.
Yeah, it's fully configurable, so you don't. So you can also deploy it in Sepolia, but for Sepolia we did not set all the addresses. But I mean, it's possible basically to deploy it to either Sepolia, Goerli, or Ethereum. So all the networks supported by Starknet. So yeah.
I think yes, because Ethereum now doesn't support Goerli anymore. They just support Sepolia.
It's still supported, I think, until April or May. I'm not sure, but I think they wanted to stop it this January 24 or something, but then they delay it. So it should be like still available on Goerli until like the mid-June, something like that. So yeah.
Yeah, because I'm used to test the DeFi strategy on a fork.
Yes.
And so I'll probably do that for the contract for the layer 1 contracts. Okay.
Yeah,
maybe for
you can do that, but there are some things to, like, if you want to fork mainnet, you will have, for example, to set some mock, like the Starknet core contract that receive layer 2 message, also for the bridge. You will have some more tricky stuff to do, but definitely we're going to improve this term for testing purpose, and also we'll set the Sepolia network as available. Yeah.
Okay, thank you. I will. I need to test the strategies because I need the new strategies, so it will take some time more. Okay. Thank you, guys.
And yeah, for the strategies, so you have two built-in models. So you have the saving die and the trade on Uniswap strategies that are already implemented. But if you want to build your own, that's pretty easy. Let me just share my screen. Okay. So this is the layer one repository. You have a contract, an abstract contract called strategy base that you can override to implement your own strategies. So just let's look at all of the functions. So you have the initialization that just set what's the pooling manager, the underlying token, and the yield token. You have the under report function that is going to call the right method based on the request. So each request has an action ID and an amount. So if it's deposit, just call deposit. If it's withdraw, it call withdraw. And if it reports, it does nothing. Like report case is when on the layer 2, we have some people that deposit, but the deposit limit didn't reach a certain threshold. So we don't want like to bridge, I don't know, 0.0000001 ether. That doesn't make sense because we'll pay more in gas fees to handle this on layer 1 than the actual amount that is put in the yield. So it does the deposit or withdraw and then return also the net asset value of the strategy. So the deposit, withdraw, and net asset values are functions that you will need to override. And same stuff for no, sorry, the net asset value is this function that convert yield to underlying amount, taking the total yield balance. So these are the things you will need to override and deposit and withdraw. So for example, for the savings die strategy, which is super simple, so you write the initialization. You don't forget to initialize the abstract contract initializer. You can add some sanity checks. So for example, because it's SDI strategy, I'll make sure that the SDI address I provided as the method die and that it corresponds to the underlying. For the deposits, this is super simple. Just calling the die and deposit, and the recipient is this address. For the withdrawal, there is the same, it's super easy. There is just one thing to pay attention is that if the strategy had some loss for some reasons, it can happen that the amount you ask to withdraw is bigger than the total asset you can withdraw. So you need to manage this case and yeah. But so if the total amount to deposit is bigger than the yield balance, so in this case, we are just going to withdraw the maximum, and if it's okay, we just withdraw what the request, what's the amount provided by the request. And for those two last thing to override, so this is just conversion stuff. So for ERC 4626, it's always like this. It has like those famous methods: preview deposit, preview redeem. So yeah, this can work for almost. This strategy can work for any ERC 4626 Amos. Usually they have some specification, but yeah, globally it works like this.
Okay, and the Uniswap one works for all the pools in Uniswap
Yeah.
version 3.
So as
Okay.
I told you before, like we are not going to use like intense or complex swapping method to optimize the trading and to prevent MEV requests. What we do is that we just select one pool on which one we are going to trade. So for example, we have a wrapped ST Ethereum strategy. So what it does is that it will get when we deposit, we get the slippage. So to calculate the slippage, so we have a slippage factor that is set by the admin, and we can query the expected when we deposit Ethereum, we can predict the expected wrapped ST Ethereum that we are going to receive through here it's just calling a Chainlink Oracle. From this amount, we apply the slippage, and then we can make sure that we'll have it at good price with this argument, amount out minimum. We'll have so the transaction can revert if the slippage is too tight, but we need to prevent loss while trading. Yeah, so that's how you can. But using this strategy, you can. We made one with wrapped ST Ethereum, but basically it could be on any token you can trade that are yield tokens. So DAI into whatever staking DAI, USDC into whatever staking USDC. So we are using Uniswap for yields that are not like how to say yield that price can depeg. Like when you mint a wrapped ST, for example, you will have it at the price I told you, Lido. But down the line, if a lot of people are selling wrapped ST Ethereum, it can happen that the price depeg from one ST Ethereum to one Ethereum. And so in this case, the wrapped ST Ethereum is cheaper, and we need to fix to this cheap price. So if you can sell your wrapped ST Ethereum for the half of what is provided on Lido, which like never happened, but it can happen that is 10% cheaper, for example. You don't want to mint it on Lido. You want to buy it with a 10% reduction. So here, that's why we are using a DEX better than directly interacting with Lido. But for strategies like serving DAI that you can deposit at any time, redeem at any time without any loss, you don't need to care about this. You just interact with the vault. There is no loss. You can withdraw when you want. So yeah.
Yeah, I think that probably yield token like the DAI token is easier to implement.
Yeah.
But I mean, if you know some pools that have a very high yield, you can
I'm thinking like
it's risky, you know. It's more risky, but
then you have strategy with different risk profile. So bigger happier, but it's like I'm thinking, for example, to leverage yield strategy through a lending protocol. So leverage wrap it against it. So this can be very profitable, but if the position get liquidated for any reason, like Chainlink publish a wrong price or whatever, then it's the position is liquidated and the share price will drop a lot. So
yes. Okay, gotcha. I understand. I don't have much time, so I will probably try with the yield part.
yeah, no problem.
But I will look into the pools too, so maybe I will let you know.
Yeah, cool. If you have any questions, feel free to ask. We have a group, so yeah.
Yeah, maybe I will write the contract for the yield token, but if I find something interesting, I can share in the Telegram chat if you are okay.
Yeah, it works. Okay. I don't know if you have some other question right now, but otherwise we done. Yeah. Okay. So thanks a lot. Have a good day, and yeah, take care.
Thank you, guys. Thank you, Sasha. Have a
Thanks.
nice evening.
Bye-bye.
See you. Bye-bye.